Good morning, everyone. It's been a while since I've done one of these videos, so I figured case pride today. And we're going to take today to review what you've done the last two classes, which was the scale of the solar system. So we talked about the relative sizes of the planets to one another, as well as the distances of those planets from each other and from the sun. So let's start by reviewing the relative sizes. Now, when we did this in class term one, we did this with fruit. We had a fruit display in the front of the room and we picked which fruit thought represented each planet. Well, this time you had the opportunity to either watch a video of someone creating a similar model using Play-Doh, or maybe actually getting your hands in there and doing the Play-Doh models, which some of you sent along and shared with me, which I thought was really cool. And because of that, I'm going to make sure I do that next year in class, because I know how much we love Play-Doh. And I'll probably still keep the fruit too, because that was kind of fun. But let's talk about the terrestrial planets first, because the terrestrial planets are our first four planets, or our inner planets. And those planets are small and rocky. So we know those planets should be the smallest, whether we viewed it with the fruit demonstration, created them out of Play-Doh, or just watched the video of someone creating them out of Play-Doh. So our smallest planet out of all of them was Mercury. When we used the fruit, Mercury was a peppercorn, which was a tiny flake of pepper, a little bit bigger than a pepper flake. Then Mars. Mars is our next smallest planet. And Mars we used a blueberry to represent. So your Play-Doh was probably about the size of a blueberry. Then we had Venus, followed by Earth. And Venus and Earth are very close in size. They're called the twin planets because they're similar in size and also internal structure. So those are our terrestrial planets in order from smallest to largest. Mercury, Mars, Venus, and Earth. Then as we move past the asteroid belt and we get to our gas giants, we already know by the name that they're going to be big because they're gas giants. We come encounter with our planet Neptune. Neptune and Uranus are very similar in size. Neptune is slightly smaller in size if we're talking about the diameter of the planet. And then we have Saturn and our most massive planet, Jupiter. So our gas giants in order from smallest to largest would be Neptune, Uranus, Saturn, and Jupiter. So if we put them all together after you viewed the video, created the models, and also looked at the images that I sent along on Monday, you had some questions to answer yesterday, and it should have said which planets which planet is the smallest, Mercury, which one is the biggest, Jupiter, which two terrestrial planets are close in size, that would be Venus and Earth, which two gas giants are close in size, Neptune and Uranus, and then finally the question said, list the planets from smallest to largest. So Mercury, Mars, Venus, Earth, Neptune, Uranus, Saturn, and Jupiter. Then, yesterday, you looked at the relative distances, and I gave you a couple of videos for that. And I also gave you an activity that if you were able to get outside, and it was a pretty nice day yesterday, a little cloudy, but no rain, that you were to take a walk with a family member and map out the distance from each planet to the sun by taking a different amount of steps. And what you should have noticed by doing that is not only the order of the planets from closest to farthest. So if we were traveling from the sun, our first planet would be Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But you probably also noticed that as you were taking your walk, or as you watched the video of people creating models, that the terrestrial planets were pretty close in relation to one another. It wasn't too many steps from Mercury to Venus, from Venus to Earth to Mars. And then as we got out to the gas giants, further out in space, the distance became extremely large. So by the time you got to Jupiter, you probably couldn't see any of the inner planets or terrestrial planets other than Mars. By the time you got to Saturn, you could probably barely see Jupiter and definitely none of the terrestrial planets. If you remember in class, we used a piece of register tape and we mapped out the distance the planets were. And the inner part of the solar system was kind of a little bit crowded in terms of relative distance compared to the outer part of the solar system. So the closer to the sun you are, the also closer together you are. The farther from the sun you are, the farther the distances become, the greater the distances become, especially when we get to Uranus and Neptune. So today we're going to continue our discussion with scale, but we're going to leave our solar system and we're going to come up with our cosmic address. And this is something we did before too, to see our place in the universe and just to see how things get bigger and bigger and bigger. So you're going to get a sheet attached to today's assignment, along with some videos to watch. And I'm going to pull up the sheet here so I can be looking at it as I'm talking. So excuse me if my eyes wander a little bit. And the first thing it's going to have you start with is this. It says, suppose you had an alien friend who lived across the universe billions of light years away. Suppose that they wanted to mail you a letter through some sort of intergalactic postman. So they want to stay connected too during this time. What address would you give them? So what you're going to notice is you start from the small and you get bigger. So the first thing it's going to have you do is put your street. Now, I don't want you to put your full address over, online. So just put the name of your street. And then it gets bigger to your city because your street's within a city. Then it gets bigger to a state because your city's within a state. Then it goes country because your state's in a country. Then continent, hemisphere, planet. Position from the nearest star, which means our nearest star is the sun. Are you the first planet from the sun, second, third, fourth, or so on? The name of our galaxy. The location in our galaxy. Our galaxy is a spiral galaxy, so there's really two places you can be located, either in the central bulge of stars or on one of the spiral arms. So that's what I'm looking for. The local group, which you're going to have to do some research because you probably don't remember that. The local supercluster, and then finally the biggest is going to be universe, because our universe is made up of over hundreds of billions of galaxies in the universe. So what you're going to do is you're going to fill this sheet in just so you can see what your cosmic address is, and it will give you a good idea what it means when we talk about the scale of the universe, how we go from the smallest to the biggest, just like you practice with the planets, with their sizes and their distance. Well, now we're taking it throughout the whole universe, which is hundreds of billions of galaxies. So I want you to complete that sheet. I also want you to watch the couple of videos that are attached. I think you'll enjoy them. Don't forget to mark as done when you're finished. And then what we're going to do the rest of the week is we are going to venture into material that we covered term 2. So we've kind of wrapped up space. So we're going to start looking at plate tectonics again and Pangea. We'll probably spend about a week on that, and then we're going to be delving into some new topics. So we're going to be looking at the human body, which is pretty interesting. So feel free, as always, reach out, ask for help if you need it. Talk to you soon. Have a great day.